guys, it's me, the creator of the video. I hope that you guys either learned something or this video kind of validates what you already knew before. So, okay, enjoy. So the first thing we have to ask is, what are radians? They're the measure of the angle made when the radius is hypothetically wrapped around the edge of the circle. Radians are interchangeable with degrees, and in some problems, conversion is necessary. To convert a radian to a degree, create a proportion with 180 in your numerator and pi in your denominator. Or, if you want to convert a degree to a radian, try the inverse of this. Here are some examples. If you'd like, you can work on these on a separate sheet of paper or just in your head or whatever works. So for number 20, since 90 degrees is negative, we have to subtract 90 from 360 before we actually begin conversion. 360 minus 90 is 270. Multiplying 270 over 1 by pi over 180 will give you the result of 3/2 pi. 22 is much simpler. Multiplying 135 over 1 by pi over 180 leaves a product of 27 over 36 pi. Dividing both numbers by 9 leaves 3/4 pi as the final answer. The answer provided for 23 is correct. However, it can also be solved with a different answer that falls in the same area of the circle. Since 360 can go into 1200 3 times with 120 remaining, 120 over 1 can be multiplied by pi over 180 with the answer 2/3 pi. Now we're ready to do the reverse. In 29, you simply multiply pi by 180 over pi, resulting in 180 pi over pi. The pi's cancel each other out and you're left with 180. Unlike the degree to radian conversions, you don't subtract a negative radian by 2 pi. Instead, you multiply it normally to produce the negative answer. Negative 8/3 pi multiplied by 180 over pi equals negative 1440 over 3, or negative 480 degrees. In 35, you multiply 7 by 180 and divide that by the most approximate value of pi. Your answer should be, or be close to being, 401.07 degrees. Before we get started with set values, we need to understand trigonometric relationships. First, identify the adjacent, opposite, and hypotenuse sides in relation to a specific angle, r in this case. There are 6 types of relationships that help determine the measurements of r: sine, cosine, tangent, cosecant, secant, and cotangent. Remember, so could TOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tan equals opposite over adjacent, and the rest are their inverses, respectively. I'll show you 2 ways to solve an exact value problem. One of them uses the unit circle. Determine where the radians-degree is on the unit circle and find the corresponding coordinates. Sine is y, cosine is x, and tangent is sine over cosine. So for number 1, we have a negative number. So that means we're going to have to work backwards. Since sine is the y value, then our answer will be the y value. For number 2, we just have to look at the radian value. And we see that it's at 90. Cosine is x, so the answer will be 0. We look at the number and that we see that the value is over 360. So we have to subtract 390 from 360. From that we get 30. Technically, we make one revolution out of this circle and then end up at 30 degrees. Since we're finding the tangent, we have to put the sine over the cosine divided. So you put 1/2 over 3 squared over 2. You have to do that since you're dividing two fractions. Just cancel out the 2's. You're left with 1 over square root of 3. Since you can't have a square root in the denominator, multiply both sides by square root of 3. You cancel out and you get square root of 3 as your final answer. The second way doesn't involve a unit circle, and we won't know whether the value is positive or negative. So it's important to reference this chart when you set your values up. We also need to remember our special right triangles. Since our value is at 210, we have to draw over here. Since the y-axis ends at 90 and 270, 60 minus 270 is 210, and since 90 minus 60 equals 30, then it'll be the 30, 60, 90 special right triangle. Side opposite 30 is 1, the side opposite 60 is the square root of 3, and the side opposite the 90-degree angle is 2. So following SOHCAHTOA, we get sine equals the square root of 3 over 2. Our next problem, since it's negative, we have to work backwards. Our reference angle will be 45 degrees. Since 90 minus 45 equals 45. This special right triangle will be a 45, 45, 90 triangle. Side opposite 45 is 1, both 45s, and the side opposite 90-degree angle is 2. And following SOHCAHTOA, it'd be square root of 2 over 2. Make sure it's negative because it is a sign in the fourth quadrant. For our last one, if you remember the unit circle, just pi over 4 equals 45 degrees. So it's another 45, 45, 90 special right triangle. Again, side opposite 45 is 1, and side opposite 90-degree angle is 2. Since we're finding the tangent, opposite over adjacent equals 1 over 1 equals 1. Hope you learned something. Bye.